remember that we define our angle as the ratio of arc length s to radius r, the so-called radian angle here, by taking this length and dividing by that length. This length here, and dividing it by this length here. That gives us so-called radians, which is sort of the natural angle measure for math, and is dimensionless and all the other things we talked about. But today what I want to focus on is we can invert this equation to get the distance traveled around the circle as a function of the angle, which is the convenience of this definition. We can turn back and say, if my angle is 1.5 radians, then the distance I've traveled is 1.5 times the radius around, and so on. And we get this equation here. Now we can consider the rate at which these quantities change. So we start again with s equals theta r. Then the change in s is obviously the change in theta r, but it's moving on a circle, so the change in theta r is a constant. We can bring outside and call it that this is the change in the angle times the radius, because the radius hasn't changed. And then we could divide that by some time over which that motion occurs, and we can say that delta s over delta t is delta theta all times r over delta t, which is, of course, just breaking this fraction up differently, delta theta over delta t times r. But, and this is the key bit, delta theta over delta t we earlier defined as omega, the angular speed. And we can see here that delta s over delta t is simply the rate at which the point is traversing around the circumference. It's the tangential speed. So if we think of, we have our circle, then at some moment this object it's going around here, but it acts as if it has a speed which is v. If it has a angular speed which is omega. And this relation here is super important, and oops, we'll come back a lot of what we do in this unit will involve coming back to this one way or the other, that the tangential speed of something going around a circle is its angular speed times its distance from the center. Bizarrely enough, this is not on the AP1 equation sheet. I've asked around. No one seems to know exactly why not. It just isn't there. Also, bizarrely, it is on the AP Physics C mechanics equation sheet, so a little odd, but it's probably just historical oversight. Anyway, although I usually don't say memorize stuff, I will say memorize this equation. Be aware of it, that the speed at which something is moving around the circle tangentially is its angular speed times omega. We could play the same game we had just done with the speeds and do it again. So we can say that, well, if v equals omega r, then delta v is delta in omega r, but r is constant, so it comes outside, and we have just the quantity delta omega times r. We take our division by the time it takes, so delta v over delta t, and that gives us eventually delta omega over delta t times r. But again, this thing is the acceleration around the circle, which we usually call the tangential acceleration. And this thing is the angular acceleration of the object as it rotates in that circle, which we call alpha. So we get the same sort of connection, which is the tangential acceleration that the thing feels is alpha times r. We need to be careful that this is a sub t, the tangential acceleration. In other words, the thing's going in a circle and it goes faster and faster and faster and faster, and we're talking about how much is this thing accelerating in that direction. And this is very distinct, of course, from the centripetal acceleration, which is something going around the circle and there's some acceleration which moves it towards the center of the circle. What we just found out was that at is alpha times r, and that's worth knowing. What we know from before is that AC is v squared over r, and that's still true. Although notice that here we just found that v was itself omega r. And so you could come up with a new form, because this would be omega squared over r. So AC is also omega squared r. That isn't really anything new. It's just a different way of expressing the same thing we were talking about before. It can be moderately useful. So maybe you want to remember it, maybe not. It's not the thing they give you on the equation sheet, though you can see is really easy to get to.